All right, geometry students. Mr. Stair coming to you here. This lesson is for Wednesday, December 9th. And we're going to talk a little bit about perpendicular and angle bisector. Some of this might be a little bit of review or some common sense that we can kind of employ from what we've already talked about. But this is page 3 in the notes. And really it's going to be setting some things equal to each other. Just kind of based on what we're seeing here. First thing I want to talk about is this definition of just equidistant, right? Maybe just kind of that word, it makes sense. But if we look at this picture right here, it's just, point B is equidistance from points A and C, right? One of the things or one of the reasons that we know that it's equidistant right here is because of those tick marks. Okay, so just kind of revisiting that here and keeping that in mind. All right, let's see here. All right, let's take a look here at this first theorem. And we have really the same one. It's kind of set up in a couple different ways, but it says the perpendicular bisector theorem. So I want to set this up here in a couple different ways, or one way here. And I'm going to put an if-then statement here. And what I want to tell us is if this happens, then, we can obviously conclude what is true. All right. So if I have, and again, here is the if PQ is perpendicular to XY. All right, so that's the first thing. So if we have two segments that are perpendicular, in this case, it's going to be PQ is perpendicular. Remember, that's just an upside down T. In this case, to XY. And Q is the midpoint. So XQ is congruent to QY. Then we can conclude something's true. All right. So what we can conclude is true is just that XP is congruent to PY. Right? So if all of this picture is true, basically all we know is that these two segments right here are just congruent to each other. Right? So if we had an algebraic equation, we could obviously set those equal, but basically if I know that these two are the same, 3 and 3, then I know that these two have to be the same. Right? And the converse basically just says the opposite. Right? So what I'm going to do here is I'm going to set it up the same way, but this time I'm going to put an if then. Right? So if, again, we have P being the midpoint or being equidistant from X and Y. So again, equidistant is more of a general term than midpoint. Midpoint implies that all three of them are on the same line. So again, if XP is congruent to YP, then we can conclude basically everything that was up in red on the beginning. Then PQ is perpendicular to XY, and XQ is congruent to YQ, right? So basically, it just depends on what it's giving us here. Now, this is important here because if you're trying to figure out where something can happen, like here in example 1, let's see if we can get to this here. Yeah. Application of a perpendicular bisector. When we're taking a look at this here, Mr. Lee wants to park his ice cream truck so that he is equidistant from the entrances of the roller coaster, or the roll-in coaster, and the spaceship chute. Where should Mr. Lee park? How can he determine where to park? All right, so the first thing we need to do is we need to find, the first thing that we need to do is to find the midpoint between point S, that's spaceship shoot, and point R. So that's the first thing. So I'm gonna, again, just kind of connect it here. And it doesn't have to be this specific dot, but we'll just say that this right here is the midpoint. We'll call that point A right there. I know it's the midpoint in real life because I've actually measured it. Whether I know, how long that is, just in general. Anyway, and so the second step here, what I need to do is I need to draw a line that's perpendicular through point A. And I'm going to do that here in red. What it's going to look like here, and again, it's perpendicular. We'll just call it line L. Right? Anywhere on line L, anywhere on line L would be equidistant. The reason for that is because, again, when I could set this up here, let's see, can I use that might show purple, yellow might show up the best here. So if I just pick a point here, I know that this and this is going to be the same length, right? I could adjust that. I could go a little bit closer to both of them, right? It just kind of depends on where I want to set up and how much space I might want to have there at the fair. All right. Now, what it's saying here is what would be the point that is equidistant from point R and S, okay, so again, anywhere on this line, as well as point M and R, right? So if I went back here and found, again, just a length that's from M to R right there, it looks like, and I guess I didn't do the best job, that this point right here, C, as it says, that would be equidistant from all three of them. Okay? So just kind of keep that in mind. If you're wanting to find the best place to set up or kind of maximizing your intake, in this case, of ice cream or selling of ice cream, then that could be something that you want to look at. All right, so now we're going to use this perpendicular bisector theorem into something where you might most commonly do this. So it says, what is the value of WY? So again, we've been working on not just trying to solve for the variable and just calling it a day, but I got to think about this. It looks like I have two distances, ZX and ZY, and since it starts with that, I can tell by the converse of the perpendicular bisector theorem that 5n minus 2 is the same thing as 2n plus 7. Move your n's over, add 2, and you get n equals 3. Now again, that's not the answer. It wants to know what WY is. So please, please, please go ahead and take that number and just plug it back in. And if I do that, I get a length of 13. B has a lot of measurements on it here. Again, it looks like what is the value of OL? Just kind of the way it's set up here. I could pretty easily tell that this entire length here right here, and the red is going to be 14. But that's not what OL is, right? Remember, if we could see that in this case, the bottom where the 9 is, and the 9 right, oops, sorry about that. Pretty bad arrow there. The 9 is there, then I know that it divides it in half, right? So it would just be 7 as a final answer for OL. All right, so this happens on lengths of line segments here. It also happens for angles as well, right? So if we're looking at angles here, the angle bisector theorem, again, talks about the same thing. What it says is that if AD bisects angle BAC and AB is perpendicular to BD and AC is perpendicular to DC, then I know that my two segments there are equal, BD and DC. So let's take a look here. I know that's a lot. Again, we'll just put an if then, right? So if AD, that's ray AD, bisects, and we wanted to bisect angle BAC here, and AC is perpendicular to CD, and AB is perpendicular to BD, then BD is congruent to CD. Right, so all of that just to get those two small segments to be the same. Right, again, the converse says that if, and we'll put it here, again, the basics is the same, that if BD is congruent to DC, and we have all those perpendicular lines. So again, it was AC is perpendicular to CD, and AB is perpendicular to BD. Then we know that angle BAC is bisected. Again, then it was AD bisects angle BAC there. All right, so we can put into practice here what that actually is going to do. Again, if we just look at a couple equations, these will be the last two that we'll look at here. It says if, right here on example 3, part A, if HI is 7. So again, HI is 7 right there. That's kind of hard to tell. So let's see if I can draw. See what's going on here. So this right here is going to be 7. And IJ is also 7. Again, so what that means is that we have an angle bisector, because those two lengths are the same. If HGI, okay, so again, still a little bit tricky here, just with how small this is. So if it's HGI is 25, we want to know what IGJ is, right? So if 1/2 is 25, then obviously the other half would be 25 in this case degrees. All right. Let's go ahead and erase this. The reason I want to erase it is just because we have part B here. If we're looking at part B, part B says HGJ is 57. So HGJ, so that's the entire thing here. The entire thing is 57 degrees. If IGJ is 28, so again, that's the bottom of the half. So that would be this part right here is 28 and a half. And HI is 12.2. What is IJ? Well, again, the whole point of us trying to get this set up is to make sure that the angles are being bisected. If the bottom is 28 and a half, we know that the top also has to be 28 and a half in order for it to add to be 27. So, again, what it's asking for is just this segment right here. Well, we've already established that it is an angle bisector. And so 12.2 is my final answer. Again, it has to be the exact same as what's above. All right, last example we're going to do, part A. How far is point R from MN? All right, so again, what we need to do here is to figure out the distance from R all the way to M. Well, we don't want to say 7x. We actually want a number here, right? So what we're going to do is, because we can see that the angle is being bisected here, notice that this right here just means that we have a bisected angle. So what that means is now that I could set them up. 7x is the same thing as 2x plus 25. And x equals 5. Well, we're still looking for MN, and so that length there, just by plugging in 5 in for x, that's going to be a 35. Excuse me. Again, just looking for that right there. There it is. That's our final answer, is 35 units for that. Well, it does say what's RP. Wait a second. I could plug 5 back in again, but if I did use my relationships, I would know that RP and MN are going to be the same there, right? Now, wait a second here. We're asked to find MN, right? How far apart is R from MN? Yeah, okay. I just want to make sure that I was answering the question here, right? The length that R is away, right? Now, we could obviously measure that in a lot of different spots. But when they say how far is it, we're always talking about the shortest distance here, all right? All right, guys, so take a look at that MathXL assignment. I'll have it linked up in the Canvas page. And we will see you guys on Thursday or Friday.